All right, guys, today I'm going to talk to you a little about limiting reagents. The whole purpose of limiting reagents is when you take two separate elements and add them together, more than likely one of them is going to determine how much product you get. So the simple way to look at it is a simple little formula where I say, if I need 2 tires and 1 frame to make 1 bike, how can I find the limiting reagent? Well, if somebody said, I have 10 tires and 1 frame, I can still only make 1 bike. So the frame would be the limiting reagent because it's dependent on how many frames I have. Vice versa, if I have 2 tires and 10 frames, I can still only make 1 bike because I run out of tires long before I run out of frames. So that's kind of the gist of what we're doing here. So the chemical formula for this stuff is not too much different than what you just saw. So here's one chemical formula. Notice, don't panic that I changed the word frame and bike and tires. I just replaced them with little chemical compositions. Not a big deal. We can figure out their molar mass, just add them up on the periodic table. Not a whole lot's changed. So we need to find out if I have what my limiting reagent would be if I start out with, let's say, 2 grams of ammonia and 4 grams of oxygen. If I add these two together, which one's going to be my limiting reagent? Well, key is ratios, just like on unit conversions. So the way we do this is we start out with our 2 grams of ammonia, and we're going to draw our little railroad tracks again, and I'm going to figure out the molar mass of this because I have to convert it to moles. That's the key to limiting reagents. We're going to be dealing with these numbers out front, and I like to call these molar coefficients. So if they give it to you in grams, you have to go to moles. Always, always go to moles. So the first step is converting the amount of grams I have into how many moles I have. Well, the molecular mass of this ammonia is going to be 17 grams per 1 mole. And notice my grams are on bottom, so my units are going to cancel. Now the next step is I need this ratio to bring it all together. Well, I know based on these coefficients for my balanced equation that if I have 4 moles of ammonia, I should make 4 moles and 6 moles. It doesn't matter what product you choose, as long as you choose the same product for both equations. That'll make sense in a minute. So what I'm going to say is I have 4 moles of NH3 should give me 4 moles of NO. And when you multiply across the top, divide, and then multiply everything on the bottom, you're going to see our units are going to cancel here. Grams of NH3, moles of NH3, and the units that I'm left with are moles of NO. So once we do all the math, we realize that we should get 0.12 moles of NO. That's step 1. Now step 2. We need to figure out how much we're going to get with the oxygen. So we're going to do the same steps we did here, except we're just going to use oxygen instead of this NH3. So if I start out with 4 grams of oxygen, 1 mole of oxygen is 32 grams. Keep in mind, when you look on the periodic table, oxygen is going to be 16, but this is O2. So you have to take into account that there's actually 2 oxygens here. That's why it's 32 grams. And then again, I'm going to look at my ratio. So if I start out with 5 moles of oxygen, I should produce 4 moles of NO. So my moles of oxygen are on the top here, so this is going to go on bottom. and my moles of NO are going to go on the top. And this gives you 0.1 moles of NO. Just a quick unit check, make sure everything's in line. All my units are going to cancel. I'm left with my units of moles of NO. And you can see that the lesser of these two numbers points to my limiting reagent. So if I start out with this amount on each side, my oxygen says, all my oxygen is going to get used up, and I'm only going to make 0.1 moles. That's the key, and that's your limiting reagent. So the other way you can do this is you can figure out, if they give you moles, you can skip this step, because this is step 1, converting to moles, and you can jump straight to your ratios. And then if they ask for it in grams, all you have to do is simply convert this many moles into grams, and that'll be your final answer. So good luck, and I hope that helped.